Hello everyone and welcome to today's video lesson. Please get out your necessary materials, your iPad, open a OneNote or a piece of paper, something to write with, and of course your factor chart. Remember, you will be required to submit your notes for today's lesson on Canvas, so don't get caught slipping. Get what you need and let's jump right into it. Today, we will begin learning how to use factoring, which we did in the last couple lessons, to solve quadratic equations. So remember how I was saying that I was starting slow so that things would come together? This is what I mean. This is the bread and butter. I didn't just teach you Xbox. I didn't teach you the X game. I didn't teach you the GCF for no good reason. It was all leading up to solving by factoring, which tends to be an overwhelming process at first, but hopefully by breaking it down into these separate skills and practicing them and getting better, by now we're going to feel not as overwhelmed. And as we continue to practice them, we're going to get better and stronger. So go ahead, get your materials, buckle up, and let's hop into it. Okay, so first things first, I'm actually gonna do something kind of crazy and I'm gonna just show you the answers. I'm gonna show you the answers. It's called revolutionary, right? And so here are two separate problems, one on the left and one on the right. You can see that the two answers are boxed in red and blue, right? So I'd like you to just take a second and on this part of your notes, just take a second to annotate. Write down, what do you notice? What do you wonder? And I'm not really gonna give away any information right here. So go ahead and just pause the video and let me know, what are you seeing here? What's going on? Because this is the goal. I want us to be able to do stuff like this. But before we get into the process of that, I want to know what you notice. What do you see? Come back to me and we'll talk about it. Okay, so I hope you had a second to kind of check it out. I'm envisioning people are saying things along the lines of well, I see an equation to start and that equation's equal to 0. So maybe that's something people are noticing. I am anticipating people being oh, X is a liar. We have X plus 4 and an answer of -4. X minus 3 in our equation and the answer of +3. So I think that might be something that people are noticing for the left equation. I'm hoping people are noticing that they set 0 equal to each piece. So the first set of parentheses and 0 is equal to the second set of parentheses, right? And hopefully seeing that it's nothing too crazy, right? The one on the right is a little different, right? There's only one set of parentheses, but we still know this is factored form because factored form we define to be breaking things into pieces that multiply, right? Parentheses mean multiply. So you might see oh yeah, there's 0 and there's a set of parentheses. Maybe you'll notice that you set 0 equal to the first thing and 0 equal to the second thing, right? It might feel weird that the first step is done, 0 equal to X, it's just over. There's nothing else to do. But when we think about it, I got X equals a number. Perfect. That's amazing. And then the last one on the right, 0 equals 2X plus 5, might be a little tricky to kind of follow what the math was doing, but essentially they just minus 5 on both sides, right? And then they got 0 minus 5 is -5 equals 2X divided by 2 on both sides. Oh, -5 over 2 is X, right? So this is the goal. This is what I want us to achieve. This is what I'm looking for. And you also might notice that one answer is a whole number, oops, and one answer is a fraction, right? That might be something that you're wait a minute, I did not sign up to solve with fractions. But remember, sometimes things don't line up perfectly. And a lot of times from our parabola project, we noticed that the numbers and our x-intercepts were really messy. And so that's just something we have to embrace, that not always the numbers are going to work out to be perfect whole numbers. But yeah, sometimes you'll get a fraction and that's totally okay. So again, to summarize, hopefully you notice that the equation is set to 0 to start. Hopefully you notice that the equation to the right of the equal sign is factored, meaning this whole piece right here is in factored form, and factored forms can look differently as long as things are multiplied. Hopefully you're noticing that each piece of the factoring, each thing that is being multiplied is being set equal to 0. And hopefully you're seeing that like we get an answer. We get an answer for x, and that answer is a number, right? Whether it's a fraction number, whether it's a whole number, whether it's a positive number, whether it's a negative number. And so these are the goals of what we want to do moving forward today. I haven't taught you anything so far in this video about what to do. Or how to do it. We've just looked at what it kind of looks like. And so let's just jump right into it. I feel like the earlier we get into it, the better it's going to be. But essentially, you can break down solving quadratics into 3 steps, really. We don't need the last one here, so I'm going to just cross it out for our purposes today. I just need steps 1 through 3, right? So remember that when we're solving, we're finding the roots, we're finding the zeros, we're finding the x-intercepts, we're finding the solution. And a lot of times, like instead of graphing, we can do it by factoring, right? So step 1 is going to be set the quadratic equation equal to 0. Okay, that's going to be step 1 straight out the gate. Step 2 is going to be to factor the left side or the right side, factor one of the sides. And lastly, set each factor equal to 0 and solve for x, right? So 3 is kind of like 2 steps all in one. And here's our very first equation, so we can kind of see how to set this up. We are given y equals x squared plus 3x minus 10. Let's start with step number 1, saying 0 is equal to x squared plus 3x minus 10. Or you can set it equal to 0 on the right-hand side. It doesn't really matter. So boom. Step 1, set the quadratic equation equal to 0. Step 2, factor. It says the left side. It's wherever the equation is, fam. It doesn't matter what side it is. Just factor the equation. That's all we really need. So we're ready to factor x squared plus 3x minus 10. That's what we've been practicing. And so we can use the Xbox method to help us do this, right? I'm going to take a times c. 1 times negative 10 is negative 10. And put 3 down here. So I'm thinking of 2 numbers that multiply to negative 10, but add up to 3. I'm talking about factors 5 and 2. One of them needs to be negative, so it'll be this one because 5 minus 2 is 3. Once I have my x, I set up my box. The first value, x squared, goes in here. The last value, minus 10, goes right here. And then 5 and negative 2 go in their respective boxes with the x. Now I'm ready to factor out my GCF from all of the parts of my box. I'm factoring out an x here, a negative 2, a x here, and a 5. And of course, always do not proceed until you check your work. X times x is x squared. X times negative 2 is negative 2x. 5 times x is 5x. 5 times negative 2 is negative 10. Sweet. So all of that is just a strategy to help us factor. That actually is just helping us factor, right? So really, that was all happening behind the scenes. So I'm actually going to move all of this work just like off to the side. So you saw where it was happening, right? But really, remember, my goal was to factor this equation. I still have 0 here. And instead of x squared plus 3x minus 10, my Xbox method just helped me factor this expression into x plus 5 and x minus 2. So you'll see this was step 1 of the solutions I was just showing you. They were already in factored form. It is really easy to solve quadratic equations when they're factored. It's only 2 or 3 steps tops to actually get x alone. So that's why this is a desired strategy, because factoring makes this process a lot quicker. The other strategies that we're going to be learning the rest of this year are a little bit longer, so that's why factored's kind of favored. Okay, step 1, set the equation equal to 0. We did it. Step 2, factor it. Perfect. Step 3, set each factor equal to 0 and solve it for x. Okay, easy. I could set 0 equal to x plus 5 and 0 equal to x minus 2. Those are both of the sets of parentheses set equal to 0. And now I'm ready to just do some math to get x alone. On the left, I'm going to minus 5 on both sides, and I end up with negative 5 is equal to x. On the equation on the right, 0 equals x minus 2. I'm going to add 2 on both sides because my goal is to get x alone. 2 equals x. Nice, right? These are my 2 answers, and I was just following my steps, right? I set the equation equal to 0. I factored it. I set each factor equal to 0. And then I solved it to get x alone. Those are the steps that we're going to use repeatedly. And it might feel like a lot at first, but remember, when we were little, we had to learn how to sit up, and then we had to learn how to stand, and then we learned how to walk before we learned how to run. So we're not going to go 0 to 100 right away. It's going to be a process, and that's just a natural part of learning. Xbox helped us factor, and it ended up being pretty good. And the more we practice actually practicing using those strategies, the stronger we're going to be. So let's pop into it, okay? I put the top 3 steps up here. Set the quadratic equal to 0, factor, set each factor equal to 0, solve each factor for x, just as a little guide so you remember what to do, because it is a multi-step process. So here's 2 more equations we want to solve by factoring. X squared plus 4x plus 3 equals 0. You'll notice that it's already step 1. Set the quadratic equation equal to 0. Check. Now is the process where we're going to need to factor x squared plus 4x plus 3. Is there a greatest common factor here between 1x squared, 4x, and 3? No, there's not. Is a negative? No, it's not. So we're ready to jump in to the x box, right? I think I need to move my box over a little bit. Yeah. Okay. So first things first. In the x, I have 1 x squared. So a times c, 1 times 3 goes up top. And the middle term goes in the bottom of the x. And so I'm thinking of a number that multiplies to 3, but adds up to 4. Easy. That one's going to be 3 and 1. Once I have my x, I'm ready to fill in my box. The first term, x squared, from this part of the equation goes right here. The last term, 3, goes right here. And then I'm going to fill in 3 and 1 from my x box. Now, something I haven't really said as a way to remember this is it's the x, right? So you're going to tack on an x to those values you found using the x. It's a reminder. If we don't have that, then the Xbox strategy doesn't fully work. So it's something I want to keep in mind. And now we're ready to factor out the greatest common factor, that very first skill we were working on when we started factoring. From the top, x squared and 3x, they share an x. That's the greatest thing they share. 1x and 3, they share 1 as their GCF. X squared and 1x, they share x. 3x and 3, they share 3. Please make sure you're checking your work. X times x is x squared. X times 1 is 1x. 3 times x is 3x. 3 times 1 is 3. Now we're ready to rock and roll for step 2, which said to factor the equation. So x squared plus 4x plus 3 is equal to 0 is the same thing as x plus 3 and x plus 1 is equal to 0. I have successfully factored my equation using Xbox. Now I'm ready to set each factor equal to 0. X plus 3 equals 0. X plus 1 equals 0. And finally, I'm ready to just like get x alone all by itself. Take away 3 on both sides. Whatever I do on one side, I do to the other. I end up with x equals negative 3. Subtract 1 on both sides. I want x alone. I get x equals negative 1 for my 2 solutions. I solved each piece for x. Now, something I haven't brought up so far is the reason why we set each piece equal to 0, step 3 in yellow, the reason why we set each factor equal to 0 is if you think about it, we're saying that 2 things multiplied together equals 0, right? And this is something called the zero product property, which just says like if you have things that are multiplying to be 0, either the very first thing you're multiplying is equal to 0 or the second thing is equal to 0, because we know anything times 0 simply becomes 0. So here we don't know which one, so we're setting both to see what they would be. And actually what we're finding for x is the x-intercepts on our parabola because it's set equal to 0, right? And we know x-intercepts are where y is equal to 0. The y was our equation. We're setting it equal to 0. It's so cool. Let's try example 2. Sorry, I got excited in the explanation. Step 1, set the quadratic equation equal to 0. Boom, already done for us. Step 2 is to factor it. Incoming x box. All right, here's the x. Here's the box. Does x squared, 11x, and 24 have a being negative? No, it's positive. Do they have a greatest common factor? Just 1. So I can move on. I have 1x squared and 24. 1 times 24 is 24. I'm always multiplying the first and the last number to get that top part of the x. 11 goes in the bottom. So I'm thinking of 2 numbers that multiply to 24, but add to 11. Multiply to 24, but add up to 11. If this is a little difficult for you, remember you can use your factor tree. You can use your factor chart. I'm looking at mine right now. 24 has 1 and 24. 2 and 12, 3 and 8, 4 and 6, right? Those are all of the numbers that multiply to give you 24. So you want to know which ones are going to add up to 11. 2 and 12, that's not going to do it. That's 14. 1 and 24, that's 25. That's not going to work. 3 and 8, 9, 10, 11. Hey, there we go. That's how we know it's 3 and 8. You're doing this like guess and check process. The more you refer to the factor chart, the better you're going to get at it. It's not 4 and 6 because that's 10, right? There's always going to be just one solution to the x. So just be extra careful. Remember, you have access to a calculator if you think they might be 2. Okay, once I have the x filled in, now I'm ready to fill in my box. First part of the x of the box is going to be x squared. 24 goes in the last part. And what I just found, 3 and 8 go in the other spaces. They came from the x, so we'll tack on the x. Now we're ready to take out the greatest common factor from all parts of the box. X squared and 3x, their GCF is x. 8x and 24 is going to have a GCF of 8. X squared and 8x has a GCF of x. 3x and 24 is going to have a GCF of 3. Always double check. X times x is x squared. X times 8 is 8x. 3 times x is 3x, 3 times 8 is 24. It's also a really cool way if you forget, like if you're struggling with 3x and 24, what's the GCF? Remember that you only had x up at the top and you know that it needed to be 3x. So it's also a cool way to verify if you're not sure that you pulled out the greatest common factor, what you know it's supposed to be, because you know what it's supposed to equal inside that box. So it's kind of fun. Okay, step 1, set the equation equal to 0. It was given to us. Step 2, factor. So once I've done the x box, I need to write my equation in factored form. I need to. I haven't actually factored it until I write it in a set of parentheses, however that may look. This is going to be x plus 3, x plus 8. Remember, if there's no numbers in between here, no signs, they're positive. If they were negative, you would have factored out a negative. So, boom. Step 2, factor our equation. Now we're ready for step 3. Set each factor equal to 0. That means x plus 3 is going to be equal to 0, and x plus 8 is equal to 0. Again, that zero product property that says if you're multiplying two things together and it's 0, either the first thing, x plus 3 is 0, or the second thing, x plus 8 is 0. And now all we have to do is get x alone. Finish and solve. Minus 3 on both sides for our first equation. We get x is negative 3. Minus 8 on both sides for the second equation. We get x is negative 8. What definitely would start off as a daunting task ended up not being too terribly bad. Had we not had the Xbox method, it could have been really challenging to solve this puzzle, to rewrite something that started in standard form into factored form and make sure that they're equivalent. There's a lot of guess and check in other strategies for factoring, for rewriting something in multiplied form, but I really think that the Xbox method is setting us up for success. Okay, hopefully we're feeling like we're getting the hang of things. I want you to try example 3, pause the video, and I'm going to just give you the answers. So I'm not going to show you the process, but I'm going to give you the answers, and I want to see if you can get it. So pause the video, try out number 3, and let's see if you can get it. Oops. All right. Did you get x equals negative 2 and x equals 1? If you did, give yourself a major pat on the back. You did it. You got it right if you got both of these values. I'm going to do number 4 for you together as well. Number 4 is a little bit harder. The numbers are a little bit bigger. So I just wanted to take this one on just to make sure that we've got the process and we're starting to learn and figure out what to do. Remember, set the equation equal to 0, factor it, set each factor equal to 0, and then solve for x. Those are our goals. X squared plus 6x minus 27. Do they have a GCF? No. Is x negative? No. If the answer to both of those questions are no, then we can move to Xbox. We've got our x. We've got our box. I've got 1x squared times negative 27 is negative 27. Positive 6 right here. So I'm thinking of two numbers that multiply to negative 27, but add up to 6. So I'm going to look at my factor chart at 27. I have 1 and 27, 3 and 9. It's going to have to be 3 and 9. Those are the only ones, like 9 take away 3 gives me 6. And hey, I also need one of the numbers to be negative because negative 3 times positive 9 is negative 27. Once I have this, I can plug in to my box x squared minus 27 and take the values that I got from my x. it's time to factor out the greatest common factor in all ways. The GCF from x squared and negative 3x is x. The GCF from 9x and 27 is 9. The GCF from x squared and 9x is x. The GCF from negative 3x and negative 27 is going to be minus 3. Double check your work always. X times x is x squared. X times 9 is 9x. Negative 3 times x is negative 3. Negative 3 times 9, 9, 18, 27. Yep, it's negative 27. Perfect. You always want to make sure you check your work before you go to step number 2, because that's how you know you factored correctly. It's like you're checking yourself before you're literally wrecking yourself. That's amazing. Okay, so now we have to factor the equation. We need to write it out though. X minus 3 times x plus 9 equals 0. I've officially factored the expression. Now I'm ready to set each factor equal to 0. X minus 3 equals 0. X plus 9 equals 0. And now that I've done this, I just have one thing left to do, and that's get x completely alone. Add 3 on both sides to the first. I get x is positive 3. Take away 9 on the second equation. I get x equals negative 9. And boom, I have officially solved for x. I know I've solved when I got x equal to a number. Let's keep them going. What I would like to elect for you is I want you to do 7 and you to do 6. I'll take the liberty of walking us through 5 and 8 on this slide. And then you're going to choose a problem from 11 and 12 and choose 2 to solve from the last 4 problems. So you can see that we just have a couple more to go. Let's jump into it. X squared minus 10x plus 21. Do they have a greatest common factor? Nothing bigger than 1. Is A negative? No, it's not. I'm ready to move in to the X box. 1x squared times 21, that's 21. Negative 10 goes down here. So I'm thinking of 2 numbers that multiply to give me 21, but they add up to give me negative 10. That's going to be 7 times 3 is 21. However, it needs to be negative. 7 plus 3 is positive 10. If they're both negative, a negative times a negative is positive 21. Boom, there we go. Ready to fill in our box. X squared, 21, minus 7x, minus 3x, excuse me. And we're factoring out greatest common factors. This is going to be x minus 3, x minus 7. Check our work. X times x is x squared. X times negative 3, negative 3x, negative 7x, negative 7x, negative 7 times negative 3, positive 21. Okay, I have used that strategy to help me factor x squared minus 10x plus 21. That is x minus 7 and x minus 3. Now that I have it factored, I can set each factor equal to 0 and solve. I get x equals 7. X equals 3. Boom. 5 done. Again, to recap, we start off by setting our equation equal to 0, factoring our expression, setting each factor equal to 0, and lastly, solving for x. Number 8, I'm going to do as well. I'm going to do 5 and 8. You have to do 6 and 7 on your own. X squared plus 8x plus 16. Do they have any GCFs in common? They could have almost had 8, but x squared, that's just 1x squared. So no, A is positive. We're ready to move in to our X box. Okay, 1 times 16 is 16. negative 8 goes in the box. I'm thinking of two numbers that multiply to give me 16, but they add up to give me negative 8. I have 1 and 16, 2 and 8, 4 and 4. It's going to have to be 4 and 4. Those are the only ones that are going to give me 8, but they're both going to be negative again. Put minus 4x in here. And now I'm ready to take the greatest common factor out of all parts. Greatest GCF of x squared and 4x. Negative 4x is x. GCF of negative 4x and 16 is going to be negative 4. You might be wondering why. The hint to tell if you're going to factor out a negative when it doesn't look like it is look back at the numbers you pulled out here. X squared and negative 4x is x. Negative 4x and 16, I'm also going to take out that negative 4. Now, when I check my work, if they weren't negative 4, I would have to make adjustments, but x times x is x squared, x times negative 4, negative 4x, negative 4 times x, negative 4x, negative 4 times negative 4 is positive 16. Something really important, the reason I'm taking out a negative 4 instead of positive 4, even though you're thinking minus 4x and 16, they don't have negatives. They both don't have negatives. Remember, we said 16 is negative 4 times negative 4, right? Even if you look back at all of our other problems, like negative 7, negative 3, negative 7, negative 3, they were outside the box. Negative 3, 9, negative 3, 9. It was outside of the box, right? 3, 1, 3, 1. It was outside of the box. Positive 3, positive 8, positive 3, positive 8. They're outside the box. So the X is actually really, really helpful to make sure you're factoring out the GCF correctly. You should definitely use that as a strategy. That's something I just noticed right now. Positive 5, negative 2, positive 5, negative 2. How cool is that, you guys? That's amazing. Okay. Set our equation equal to 0. It was given to us. Step 2, factor our expression. X minus 4 equals 0. Now we're ready to set each factor equal to 0. X minus 4 equals 0, and x minus 4 equals 0. You might be wondering what happens when they're the same equation set equal to 0. The math's just exactly the same. It's super easy, so don't stress about it. You just get x equals 4. So it's really one answer that's the same answer, and that's totally okay. So again, set our equation equal to 0, factor it, set each factor individually equal to 0, solve them to get x. 6 and 7 are your homework to try. And I'm going to actually stop this video right here and leave 6 and 7 for you to do and have the rest go into the next video because I forgot. It's Short Wednesday. So I'll see you in the next video, guys. Thanks so much.